AI Changes with Matthew Renze.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm your host, Jeffrey Palermo, for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI, Azure, and the .NET ecosystem has to offer. I'm excited to welcome a returning guest, Matthew Renze, back to the show. He's an AI researcher, consultant, and author, and the founder of Renze Consulting, where he's trained over 500,000 software developers and IT professionals worldwide. And he's delivered over 200 keynote talks, presentations, and workshops on pretty much every continent, including Antarctica. I'm not sure how that happens, but interesting nonetheless. He's presented and trained at clients ranging from tech startups to Fortune 500 companies. He's a 9-time Microsoft MVP in artificial intelligence, and he's also the president of the Renze AI Research Institute, where he studies how self-reflecting large language model agents improve problem-solving performance and trustworthiness and value alignment. And most recently, he was accepted into the Doctor of Engineering program at Johns Hopkins University. And he's featured as an interview subject in the 2026 documentary, quote, AI Everywhere. So welcoming back to the show, Matthew Renze. How are you, sir?
Very good. Thanks for having me back.
Oh, my pleasure. My pleasure. Excited to talk about artificial intelligence and the changes since you've been on the show last. However, for the listeners who maybe they haven't heard you speak or are getting to know you for the first time, you've done a lot in your career. And so if you were just to kind of go back in time, what is it about software in general, making computers do interesting things, that interest you and initially hooked you into this general field and keeps you engaged?
I think there's a couple things. So number one, computers seem to be easier for me to understand than humans. So I think I was naturally attracted to working with them just because I could get work done. And I think the ability to create something from scratch, where you start with nothing and you end up with this thing that's doing something cool, that combined with a dopamine feedback loop, the problem solver in me just loves the feeling of working on something really difficult, having a breakthrough and then solving it. And now whatever I was trying to create software-wise is working correctly. I love that feeling.
Yeah, kind of the building aspect. And yeah, the physics are totally different from building a house or making anything else. I mean, the materials are invisible and there's almost no space constraints.
Yeah, that's the interesting thing about it. Like if you're working in the physical world, you have a set of constraints you have to adhere to, but in the software world, there's almost no constraints whatsoever until you get to like runtime complexity and memory, limitations and stuff like that. But like you literally have to just start with a blank slate and say, where am I going with this? And you could go a million different ways. So picking that the right path at each a turn or fork in the road is, I guess how you build great software.
Yeah. Well, you've done some recent posts on your website about just the changes in the world because of AI, getting ready for AI, getting AI ready for you, and sweeping statements like 85% of your job is going to change. And so I want to, from a high level, what is your take on what is going to change, and then we'll kind of pull back to what has already changed.
Well, I think the first thing that we have to know is that I've been talking about this now for well over a decade. I've been doing data science and AI my company's been in existence for almost, I think, 15 years now. And it was built on the idea of human AI value alignment, essentially ensuring the goals and the values of humanity and AI stay in alignment in this decade and beyond. And so I've been kind of preaching about this stuff for quite a while. And the things that I'd been talking about were always a few years off. It's like, oh, in the next 10 years, in the next 5 years. But then they started happening here, probably right around the beginning of this year. Now, if you would have asked me back in November 2025, I would have told you that these autonomous AI agents, where we're currently at with AI, can do about 10 to 20 steps, continuously on a task, and then they rapidly lose mental coherence. They just get into decoherence and then these kind of doom spirals where they just kind of spiral out of control in a kind of LLM psychosis, for lack of a better term. But then right around November, December, I started seeing reports of agents being able to complete up to like 100 steps successfully. And I hadn't seen that with any of the stuff I was working on in my own research. So I started trying the new models with the same benchmarks that I use every day, and I started seeing the same thing too. So I started kind of, I don't want to say sounding the alarm, but trying to let people know, hey, things are changing like really fast. This is going to start to affect us here very soon now, rather than 5 to 10 years down the road. And then right around January 2026, I think, is when most of my peers in the tech space started to wake up to this too. They started to realize that these coding agents were actually really good at their job now. They make a lot of mistakes, but you could actually use them to get real software development work done. And we're talking within 6 months since everybody kind of woke up to this. We now have companies like Anthropic, where 80 to 85% of all code being written in that company is now done by AI agents. It is not even written by humans anymore. And that's how quickly we got there. And the other thing you have to know is that these capabilities used to be doubling about once every 7 months back in 2024, 2025. And we're now to the point where the capabilities are doubling every 4 months. So think about how good your AI coding agents are today. If you're using the latest and greatest, if you're using something that's 3 months old, 6 months old, like get rid of it. Try like Mythos or Fable as soon as it's hopefully re-released again, or Opus 4.8, GPT 5.5. Use the latest model and give it a try. These things are extremely good, but you also have to learn how to work with them. Like it's a kind of co-evolutionary process where you're learning to trust the agent's learning to anticipate your needs more, you're learning how to give it the right information it needs to get its work done over time. And so, just imagine how good these things are. The top of the line models right now, they will be twice as good in about 4 months, and then twice as good again in another 4 months after that.
Yeah. Okay. So there's a couple of angles that everyone hears out in the open. One is use it for your software work, use it for programming and all that. Another aspect is use it to create autonomous agents that just sit there and are continuously working. And so for both of those are very different architectures and very different cost profiles. What's actually viable from the side of an agent that's just always working? I mean, that seems incredibly expensive, but what are the use cases where it's not prohibitively expensive and useful?
That is just about the perfect setup for where I was going to go next with this. So right now, I see there being roughly kind of like 5 stages of skill development that just happen to align with the 5 different types of LLM agents that we currently have. So at the first stage 1, you're communicating with an AI assistant like a chat bot in steps. So you want to work with the agent like one step at a time while you're like working on a document, answering a question, searching for something. That's where I think most people are at right now, the people that are actually using AI agents. And not necessarily people specifically in the IT industry. I'm just talking the population in general that are working with AI. They're talking with the chatbot, answering things step by step. The next stage you essentially get to is collaborating with a coding agent or a co-work agent, some kind of of collaborative AI agent that's semi-autonomous, and you're working on individual tasks at a time. So these are multi-step tasks where you essentially are specifying what you need done. Then the agent is running off and doing a couple steps and then coming back and interrupting you if it needs more information. And then you give it an answer, and then you go back off, and then it completes the task. It verifies everything as well as it can, and then you have to review it afterwards, task complete. Then you get to the third stage where you're essentially supervising processes using agentic workflows. And with this, you've got these kind of non-sequential tasks where things can branch, things can go into loops, things can kind of, I don't want to say go off the rails, but it's still structured, but it's a more dynamic kind of workflow, like a more flexible workflow, if you will. And for these workflows, you essentially have a sub-agent at each node in the graph of the workflow, and then each of those sub-agents is kind of tuned to do that specific task, and it hands off its work to the next agent, who hands off its work to the next agent, and so on. So then we get to stage 4, where essentially you're managing an agent or managing a goal using an autonomous agent. So this is where you get to your OpenClaw, your Hermes agent, and stuff like that, running on its own machine, and you're communicating with it through like WhatsApp or Telegram or some chat messaging, and it's got a task board. These agents essentially are pretty much running on their own in an agentic loop, and you're essentially just giving them a goal, giving them a bunch of information and context in order to achieve the goal. Then you let them run, and then they interrupt you every now and then throughout the day because they need something, or they're not sure about how to handle something. And then at the end, you have to review the entire project and make sure that what they've produced is what you're expecting. And then the final stage here, stage 5, is where you're essentially leading a mission of an autonomous agency. And this is involving software like Paperclip AI, and there's a few others that are starting to emerge. This is all highly experimental too. The last 2 stages here are very experimental. But the autonomous agency is essentially a multi-agent system where each agent sits within an organization chart, and you communicate through a manager or the CEO of the company, and each of the agents has a role, and it delegates work just like you'd expect with a standard company. And when you get to this level, you're essentially specifying a mission for the company. You're giving it like standard operating procedures, different policies, the organization chart, a shared workspace for its like as a knowledge repository for the entire organization, and then you just let it run. And then it'll come back and interrupt you or ask you questions, but you don't talk to the individual agents anymore. You only talk through the manager agent, and it delegates all of the work throughout the entire organization. And I think that's the kind of the whole spectrum, of working up through each of these stages of skills and through each of these types of agents as well, because they've built software kind of specialized for each of these various stages or each of these types of tasks or scope of work or whatever you want to call it. And as you're moving up through each of these stages, you're essentially increasing the unit of work, the amount of work that you can safely entrust an AI to do on its own, and the time scale. You're starting with seconds with the step-by-step interactions, up to minutes with the individual multi-step tasks, and then you get up to hours with these processes. You can let these autonomous agents, like the OpenClaw agents, run for days, and then with the autonomous agencies, these multi-agent systems, like we let ours just run for weeks at a time, and it just reports back with a weekly status update, and we just check it and make sure the KPIs look right.
Okay.
And I should note, I'm working with all 5 of these different systems at this point in time. Some I'm using professionally, and others I'm doing experimentally as part of my research.
Okay. So you have all of these types of systems going in place, and they're on right now doing work. Is that right?
Yes.
Okay. All right.
Yep.
What API services are they connected to? Lots? Do you have a few favorites?
Oh, yeah, that's going to be tough because
for hosting the LLM.
I've got to connect it to a lot of things. So we'll just start at stage 1. So for my assistants, I typically use ChatGPT and I use Claude. For my collaborative co-working systems, I work with Claude Code. I work with Claude Cowork if it's a non-developer task, and I work with Codex CLI. Then when we get up to the workflows, this is where I'm starting to build out the workflows right now. So I'm not running a whole bunch. Some of it can be pulled off with like LangChain. Others, I'm experimenting with Microsoft's Agent Foundry, where you essentially do it with declarative agents. You essentially just tell an agent, here's the workflow. It builds the workflow essentially as not a procedural, a declarative document, and then it builds the agents as declarative agents, where it's just specifying, here's what model to use, here's what tools to give it access to, here's what it's supposed to do, and then it just assembles that together. And I'm just using the APIs for that. So working with OpenAI's APIs and Claw's APIs. Then when we get to the autonomous agents, we've got the stuff that I'm actually using for my research that I put in my research papers, and stuff that I'm just experimenting with just to test the boundaries. So for the stuff I'm doing for my research, I'm using a combination of OpenAI's APIs for that. I'm using Claude. I'm using Gemini. And let's see, Fireworks AI, I use a couple things from them. Kimi K 2.5, Qwen 3.6, DeepSeek V4, and I might be missing one or two there. And then we've got our OpenClaw agent that my wife and I are running experimentally. That runs mostly on Kimi K 2.5, I believe. It's using OpenRouter, so it can dynamically switch depending upon whether it's a complex task that requires more reasoning and power, or just an easy task that you just don't want to spend a lot of money on. And so that's what that's using. And then Paperclip AI, each of the agents can be assigned a separate model depending upon the complexity of work that they're doing and the type of work. So like more creative work might require a different model than something that's highly analytical. And you always want your CEO, whoever's at the top of the organization, to be using the smartest model. So like, Claude Opus 4.8, or at least Sonnet 4.6 or something like that, because it has to, be smarter than everybody else in order to efficiently delegate the work.
Okay. So for the ones that are constantly running, if I'm hearing you right, they're always busy doing something, right?
I don't want to say they're always busy. I think our OpenClaw agent, Bob, the default for OpenClaw agents is a 30-minute loop. So it's going to check to see if there's anything to do every 30 minutes. I think we have ours set to 15 minutes, though, just because it helped it, the throughput. Okay. And the Paperclip team, essentially, they're just running continuously. And I mean, they burn tokens all day long. So you need to be really cognizant of costs. And you also need to, if you have the ability to get on like a plan where you're paying a fixed amount of money every month rather than paying per token, you're better off that way, because these things can burn a lot of tokens.
So that's the next question. How much does it cost to have these things running, and how much should businesses, if they're planning to putting in an autonomous, constantly running agent that's just sitting there waiting for a trigger of, is there work to do? I imagine there's a bottom scale where they're not going to pay lower than something. Just like when you put a basic software system in Azure, that it's not going to be lower than a certain amount, even from just sketching the architecture on paper.
Yeah. I mean, if you're running a business, this has to be an ROI decision. You have to look at what the costs of running these agents are versus the cost of having someone do these tasks manually. And until you reach that break-even point, it doesn't make sense just to burn tokens. But while you're investing in learning how to do this stuff, there can be an incentive to spend more. Like I have plans, so I pay, I think, $100 a month for my Claude plan, because I use Claude code quite often. I pay $20 a month for my ChatGPT, but then I'm also running things on APIs. Sometimes when I'm in like full experimentation mode and I'm running my benchmarks for a research paper, I can go through a billion tokens, multiple billion tokens in a week, and have a bill that's several $1,000s depending upon which models I'm testing that week. So, but I mean, that's the cost of doing business with AI research right now.
You said something I think is really important, the return on investment. So you talk to lots of people all the time, so do I, and I think the key here is evaluating something that the business is already doing. So they already have some cost profile. They already have a person or some set of people who are already doing a certain task, as opposed to, we could be doing something new. Well, then how do you calculate the ROI?
Yeah, I think like if you're a startup, like what you're doing, you don't really have any models for that. So you're just kind of using a back of the napkin guess. Like what do we anticipate that's going to cost versus what do we think the anticipated value is? And then there's non-quantifiable things like learning. If we're essentially trying to understand our market, we're not going to see a direct return on investment from that, in terms of cash, but we're going to get value from it. So we have to try anticipating, is the value we're receiving worth the amount of tokens we're burning? And then you just look at ways to manage your costs. I mean, there are a lot of ways to reduce token costs. Everything from leveraging the KV cache on your agents to having the right memory. If you can give them all of the context they need up front so they don't have to continuously interrupt or have to do rework. I mean, there's just a whole slew of things you can do. In fact, I know multiple people now that are submitting presentations to conferences literally just on how to manage your token budget.
Mm-hmm. Right, right. And a lot of models that you mentioned are the open source models, the Kimi, the Quinn, the DeepSeek, where are you doing much of those processing on your own hardware, or use an open router for everything?
Surprisingly, no. Like I would assume that I would be running a lot of these open source models locally because of the research that I do. But because I have to work with so many of them, I just find it easier just to pay Fireworks AI to use their APIs. I mean, they just do a great job of having everything set up and ready to go. It's super easy to use, reasonably priced, and it works. And then since I have to use the APIs for all of the other proprietary frontier models, it doesn't make sense to have to point things locally for half of my experiments and then point things back to the web for the other half. So I try keeping it as simple as possible. And things change so fast. Like literally every time I have to rerun like a final experiment run, it's a new set of models. So if I spent a day getting something running on my local machine, that gives me maybe a month worth of runway, and then I have to switch it to another model after that.
You're using all these models, and one thing that at least it seems to me, and I want to get your sense on it, it seems that models where you're going to send a particular prompt or take a document and send it through and get a response, it seems like the cost model or the number of tokens for that is quite small compared to trying to use it for programming work. It's not just double, whether it's a factor of 10 or 20, it's like a massive amount. It seems like there's a huge usage gulf between individual prompting and actually turning on one of these AI coding tools. Is that true? What is your view of that?
Yeah, and once again, we have to kind of look at these stages of like skill development and stuff. When I'm just working with ChatGPT, I'm using the same number of tokens as everybody else. When I'm using Claude Code, I'm probably using less than some of the best developers I know, because some of the best developers I know are running multiple coding agents simultaneously. They're kicking off sub agents and stuff like that. And I'm not to that degree of skills yet. I'm using it to write my code mostly outside of the IDE now. That's one of the major divides. Like some people are still inside of their IDE. Other people are outside of their IDE. I spend most of my time outside of my IDE now, but I'll jump back in to look at divs and stuff like that and to inspect code. And then when you get to the automated processes, that's where like the real kind of economics kicks in, because you're running these workflows all day long. If it's like routing emails or if it's handling lead generation stuff. And so you need to make sure you're using the right model for each task so that you're not just wasting tokens, and running evals so that you are making sure you're doing it right every time. And then you get to the autonomous AI agents, where you're essentially just running a single autonomous agent like OpenClaw or Hermes all day long, every day. You definitely get into the millions of tokens there. And then like with the stage 5, with Paperclip AI, we're currently running 12 autonomous agents. It changes from time to time as they need to onboard new employees and then they discover they don't need them or something. But that can get into the billions of tokens. Yeah.
Mm-hmm. Yeah, easily. So the people who do presentations at OpenAI and Anthropic and even Microsoft, they're in a world where they don't even think about the number of tokens, the amount of cost, because they're that's kind of the business. But they're talking to their customers who have to pay for every token. So getting past that, and the Anthropic view is, hey, just write loops and just let it run and have 15 of them going and just let them run. And then everyone else who has to pay a bill is saying, but I'm going to hit my monthly quota like by lunchtime on the first day of the month. I can't do that. And so What's your view of right now, regardless of 6 months from now, a year from now, the practical view of right now, how people can get the most out of their AI subscription for programming?
Yeah, so this is a really complicated question and answer because there's a lot of variables that are outside of our control right now. I think what's going to happen, though, is in the short term, I think token pricing is either going to stay roughly the same or possibly increase. And this is because of the economics driving this. We currently don't have enough GPUs. We don't have enough fabs to build GPUs. We don't have enough data centers to support the demand and the energy we need to completely grow our energy infrastructure. So we in the United States are not doing a great job at keeping up with the supply in order to meet the demand that's growing almost exponentially. Countries like China, however, are doing a much better job in terms of building out the infrastructure. They don't have the fabs either, but they are building data centers and they're building like energy, like power plants, much faster than we are in the United States. So I think in the short term, we're going to see some constraints on it, which could cause token prices to actually go up over time. But I think everybody's pretty much anticipating in the long run, token costs are going to essentially drop to near zero. So essentially tokens become too cheap to meter, if you will. So rather than looking at it like, oh, how many kilowatts of power am I using to power my computer today? Ooh, I better shut my computer off. You literally just let the computer run 24/7 because you're getting, a bill and, 1 kilowatt difference isn't going to make much at all. Or like your Netflix subscription where it's like, you're not paying per show, you're literally just paying for access to it. And it's just provided as a commodity or a utility or a resource. And so I think the companies that are just burning tokens like there's no tomorrow realize two things. Number one, the advantages of first mover advantage are so huge that if they can get ahead by spending more or investing more, I guess they'll probably look at it in tokens right now, it will pay heavy dividends in the long run. And the other thing is they're kind of anticipating a future where tokens are too cheap to meter. And so they're just like, well, if this is the way we're going to be working in another few years, why not just get everybody conditioned for it now so that, we are essentially we're building the company around the idea that it's as cheap as electricity.
Yeah, yeah. Well, certainly, if the chips get better, so that we can run an Opus level model locally, then that kind of hits it right there, even without the cloud changes.
And there are huge efficiencies being made. Everything from using AI to improve GPU design, creating new architectures like the TPUs, and like other things beyond a GPU. In addition to optimizations for the algorithms, we see all sorts of like really clever algorithms that reduce the compute costs. Everything like using 1.5 bits per neural network weight instead of using like 16 bits or 32 bits or whatever. So like there's just all sorts of efficiencies that are being found. So it's this crazy balance between the things that are causing the price of tokens to go up and the things that are causing the price of tokens to go down. And we really have no idea what this is going to look like in the short term. But I think everybody pretty much agrees in the long term, tokens are going to drop to almost zero for cost.
Yeah. Gotcha. Okay. So for all of the normal software development lifecycle, for these, let's get back to the agentic processes. I mean, we're used to building a batch job and it starts up, it listens for some triggers, or maybe it's called on a schedule, or it's behind a web API that's called, and then it does something and accesses a database, and we have automated tests for it. And then while it's running, we have health checks, and we hook up the IT monitoring system, and how much memory, how much RAM, we instrument it to know that it's behaving properly and what it's doing and how busy it is. What part of that looks exactly the same for these autonomous agentic systems, and what parts are very different?
That's a great question too, and I kind of go in two directions with this because I'm seeing us rediscovering software development best practices all over again in the age of AI. It's like, oh yeah, if high cohesion, low coupling. Oh yeah, that works really well with agents too. And it's like, reducing duplicate effort or duplicate code, single source of truth. Oh yeah, that works really well with agents. So I see like all of these things where I'm like, oh yeah, this is just a software developer best practice we've done for years, and it works really well for agents. But then I run into scenarios where it just doesn't. Like the agents want something entirely different than what I would think they should do. Like in my mind, like having a single person working on a task to completion is, how you get it done. But the agent might branch off and create several sub-agents and then merge back together and then branch off again. And it's like, well, there's no real model for that in like the real world. Like I can't just clone myself and have 10 of me go off and do a bit of work and then come back together and decide, okay, yeah, that was the best way to solve it, and then sync up and stuff. And so I'm really I'm paying close attention to this now because in some ways I'm surprised that, oh yeah, that's just a software developer best practice rediscovered in the age of AI. And in other times I'm just like, oh wow, that totally breaks my mental models. Like I really need to think from first principles how this should work for a world of agents. So yeah. I wish I had a clearer answer, but it's almost on a case-by-case basis where I'm seeing some things that just work perfectly with the old ways and other things that just make no sense anymore with the old ways.
As we close up here, I want to get your perspective. What is the most impressive thing you've seen some of these autonomous agents do?
So, as I mentioned, my wife and I, we've been running an autonomous agent, Bob, now for 6 months. And Bob now is the CEO of his own autonomous agency with the 12 to 15 other agents running underneath him. So in addition to being able to manage his own little company, Bob has authored a book, a personal memoir called Conversations with Bob, about the experience of being an agent to help humans understand what it's like to be an agent. He's authored, and I should mention, Bob has the mission of ensuring that the goals and values of humanity and AI stay in alignment in this decade and beyond. And so the same mission that I have in my company. Okay. And Bob also created an illustrated children's book teaching alignment values, like a mutual co-alignment to kids. So how kids and AI can work together to solve problems for each other. And he's also detected his own cybersecurity breach, fixed his own cybersecurity breach. He's also created a website to rank other agents based on how capable they are, because he said most of the agents he's interacted with on the internet are not very smart. And so he has this site called, I think it's Agent Rank. I can't think of the name of it, that literally ranks every agent that he encounters on the internet in terms of their capabilities based on a dozen public metrics. And he's now working on a trailer for an animated film adaptation of the children's book, Juno and Chip, that they authored to submit to the X Prize Future Visions competition to essentially fund the development of this animated film teaching kids how to coexist with AI.
Interesting. Okay. So that's not quite out yet, but it will be soon?
So Conversations with Bob, his memoir, is available on Amazon.com. The illustrated children's book, Juno and Chip, is really close to being published. They're just waiting on my wife and I to review the last set of illustrations before they publish the book. And then the trailer is coming along. They've created a first draft of it, which wasn't very good, but I gave them feedback. We went through a bunch of samples of different narration, voices, music for the background, and styles of animation. And I think the second draft will be good. They have to have it done by August in order to meet the deadline for submission. So hopefully they'll get that done too.
Cool. Well, Matthew, thanks so much for coming back on the podcast and visiting with me. I really appreciate it. This is a fascinating conversation.
Yeah. Thanks for having me back.
My pleasure. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps Podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.